All right, guys, here we go. There's another lesson, lesson 7. It's quadratic applications. We've done a lot of these already, so I'm going to try to scoot through these a little bit quickly. The hardest part is going to be on the calculator, which if you're using this, actually turns out to be pretty easy. And I'll show you why in a moment. So here, we've done a question like this before. It says the graph below shows the height h in feet of a small rocket T after it is launched, right? So here's the rocket, it's launched, and it follows this path here. When will the rocket reach a height of 100 feet? Okay, so when I go up, it's reaching 100 feet here. That's at 1 second. Okay, and they want to know what is the maximum height of the rocket. I want to know what is the tallest it goes, right? That's going to be here. Now you have to figure out what each box is worth, because really if you look here, and you scoot it over, it's one box above the 250, right? So if I go here, I know it's going up to 50 here. So it's 10, 20, 30, 40, 50. Therefore, this is another 10. So from 250 up one box is 260. Okay, so it'll reach a height of 100 at 1 second. That's when it initially reaches 100 feet. What is the maximum height of the rocket? We just said was 260 feet. At what time, which goes along here, that's the time, will the rocket reach the ground? Well, this is when it's leaving the ground, and this is when it returns to the ground, so at 8 seconds. Remember, the height of the ground is 0. All right, so if we look at the first example question, it says a foul ball, I think it's supposed to be leaves the end of a bat and travels according to this formula h of t, where h is the height of the ball in feet and t is the time in seconds. How long will it take the ball to hit the ground? Okay, so if I go to my calculator and I type that in, right, I just went to my y equals button. I typed that in. Notice I used an X instead of a T. That's just kind of what we always use when we're putting functions into the calculator. Now, when I graph it, I wonder if it'll go from scratch. So when I graphed it originally, I think it looked something along like these lines right here. And what's kind of cool is that if you're doing this on your phone or on your iPad, you can kind of just zoom with your fingers without, excuse me, sorry, without worrying about like messing with what we call the window and things like that. So I could just kind of zoom it and get exactly what I'm looking for here. Okay, so this is when it leaves the bat, and then it goes up to there, and it comes back down. I just want to know, so I'm going to zoom a little further and figure out where it's touching the ground. Okay, so here, and you can kind of move it around and mess with it. But I see it's leaving, it's going up, it comes back down, and it's hitting the ground at 4 seconds. Okay, so I'm just going to write up my answer. Okay. Next one, a rocket is shot vertically into the air. Its height h at any time t in seconds can be modeled by this equation that we have here. Determine algebraically the number of seconds it'll take for the rocket to reach a height of 529 feet. Okay, so they want to know, when is the height h? 529 feet. So 529. Okay, it says algebraically. That means we have to do it by hand without using a graph. Okay, so when I do this, I'm going to move this on over to the other side. So that's a positive 529. I'm going to subtract it. Whenever we're solving quadratics, we have to make sure that we get everything to one side, right? The first step is always to get it in standard form. So 0 equals negative 16t squared plus 184t minus 529. Okay, in my opinion, the easiest thing to utilize here is the quadratic formula. I'm not expecting you guys to know how to factor this and such. So I'm going to use my A as negative 16, my B as 184, my C as negative 529. And I'm going to lean on the calculator for this after I set up my quadratic formula. Okay, so I wrote out my quadratic formula. I'm just going to fill in my A, my B, my C. Notice that my B squared, I'm always using parentheses because if that's a negative, the parentheses make a big difference. I don't know if I mentioned that in the other videos. Minus 4A C all over 2 times negative 16. Remember, you have to do the positive just for space sakes. I'm not going to rewrite it 2 times. I think that would be the best idea, but you have to, in the calculator, do the positive version and the negative version. Okay, so I'm going to go into my calculator here. To get out of the graph, you just hit the close button right there. I hit second, quit, or second, and then the mode button, which gets you to quit to get back to the regular screen. Remember, we have to do a set of parentheses around the numerator and a separate set of parentheses around the denominator. Negative 184. I'm going to do the plus version first. Get out of the square root first, close the parentheses of the numerator, divided by, opened parentheses for the denominator, 2 times negative 16, close the parentheses for the negative 16, and close the parentheses for the denominator. Okay, and I get 5.75. I'm going to do, again, second entry. Go in front of the plus sign. I'm going to hit delete and just replace that with a minus sign to get the other part. Okay, it looks like we get the same answer either way, so that's perfectly fine. Just making sure I typed everything in appropriately. Yeah. So at 5.75. All right, so that's going to be when it reaches the height of 529 feet in the air. I'll do one more question here, and then I'll go ahead and discuss the homework with you so that you can know how to do the homework on your own. All right. Oops. A cliff diver on a Caribbean island jumps from a height of 105 feet, so that's where he is at time 0, with an initial upward velocity of 5 feet per second. An equation that models this height, h of t, above the water in feet of the diver in time elapsed t in seconds is just shown here by h of t. They want to know how many seconds to the nearest hundredth, so it's okay if we get a decimal, we'll just have to round it, does it take the diver to fall 45 feet below his starting point. That's a tricky part right there, 45 feet below his starting point. So he's starting at 105 feet. I'm going to take away 45 feet. That means they want to know, when is he at 60 feet? So just to translate this, they want to know, when is he 60 feet above the water? Okay, so I'm going to have 60 equals negative 16 t squared plus 5t plus 105. Now, I'm going to see if I could try to figure it out on my calculator here, because it does not say algebraically. So I know they say to the nearest hundredth. That is a hint to me that they want me to use a quadratic formula. I'm going to see if I can use the trace feature and try to get an accurate answer. Okay, so I'm going to get it in standard form first. I'm going to subtract . Okay. I'm going to go ahead and try to type that into the calculator. Negative 16x squared I'm going to go to graph. Okay. For this particular scenario, since I set it equal to 0, I'm looking for when it hits the ground. Okay, so I'm going to hit this trace button right here, and it'll allow me, when I put my finger, if you see that little dot right there, that dot, it's going to trace that dot. So, and it gives me the coordinates up here where the x is and where the y is. Okay, so I want to know the x value when it's going down to here. So I'm going to try to zoom in a bit. I'm going to trace and see when that dot gets down to 0. I had it and then I took my finger off. All right, it looks like it's 1.84. Hundredth is 2 decimal places. So I'm going to go here and say 1.84. To do it by hand, algebraically, utilizing the quadratic formula, you'd have your A, your B, and your C. Okay, so we're going to do x equals, and I'm just going to go based off of this one just for space. So I'm going to have a negative 5 plus or minus b squared minus 4ac all over 2a. Okay, I'm going to do the plus version first on my calculator. I'm just going to redo this part right here. 2 times negative 16. There we go. I forgot to put parentheses around the denominator. Sorry about that. Okay, so see how the parentheses around the denominator do make a difference. Okay, so they are important. So my first answer is negative 1.53. What I want you to realize is you cannot have negative time. So automatically this cannot be an answer. So I'm going to go second entry. I'm going to go in front of the plus sign, delete, and replace it with a minus sign. And if you notice, it does match 1.84. So x equals 1.84. Okay. For your homework.
Good morning, Mommy.
Good morning, kiddo. This is my kids. Sorry, they just woke up. All right, at the end of a graduation ceremony, it's customary for the graduates to throw their hats up into the air. Carolyn throws her hat into the air, and its path can be modeled by this equation right here. It does carry into the other side, so just be careful. We have height h, and t is seconds. How long is it going to take for it to hit the floor? We want to know when is it equal to 0. It does not say algebraically. I'm totally fine if it says algebraically for you typing it into the calculator and seeing when it crosses the x-axis, okay? So that's what you would do for your homework. I'm fine again with you doing it on your calculator and writing out the answer. I'm totally cool with that. Maybe just give me a quick little sentence. It hit the x-axis at this point, so it's this amount of time. All right. Message me if you have any questions. I'll try to help the best I can. We're going to do a review next, and then you have a test. It'll be all multiple choice. All right, guys. Have a great day.